looking at low intensity high duration, the dominant energy system for this would be the aerobic energy system. And this uses glycogen, fats, or proteins to generate ATP, which then cause muscle contractions. A performer which is more glycogen sparing, meaning that it takes longer for them to use their glycogen stores, so they can use other ways like using fats. They take longer to fatigue, meaning that the overall performance would be better. And the depletion of glycogen can cause hyperglycemia, which is when blood sugar levels become too low, which can become potentially dangerous. As you can see from here, you can see that fats actually hold the most potential energy, whereas carbohydrates, or using glycogen or glucose, they actually hold the least amount. So the more the performer can rely on their fat stores, the better that they can perform, due to the high amount of energy this produces compared to the glycogen stores. And also the glycogen would eventually would potentially be depleted, causing the performer to fatigue. This is important looking at this graph, which shows that the percent of the initial muscle glycogen, as this lowers over time, showing that during low intensity it takes many hours for it to drop, but as it drops, eventually the performer would get to a level where they would fatigue and their glycogen levels would be so low. A good example of this would be a triathlon, as this can last for 2 hours, approximately 2 hours, depending on the distance. But over this long period of time, their muscle glycogen stores would be depleted, or would deplete throughout it, looking at this graph. During aerobic respiration, there are three main waste products. The first being carbon dioxide, and this is then for the body to get rid of the carbon dioxide. This is transported from the muscles into the blood back to the lungs, which then can be expired out. And during this, 3% is dissolved into the plasma, 23% is transferred into carboaminohemoglobin, and then the majority of 70% is turned into carbonic acid. And this carbonic acid is made up of a bicarbonate with hydrogen ions. So these hydrogen ions can also eventually contribute to fatigue, like we spoke about during the moderate intensity, moderate duration. But these hydrogen ions come at a much lower volume, meaning that they can easily be dealt with, and takes a long time for them to build up to contribute to the fatigue. The second waste product during aerobic respiration is water vapor, and this is gotten rid of by the body through sweating. And over time, because of the loss of body fluids and water, this would cause dehydration. And dehydration would then increase the blood viscosity, meaning that the heart would have to work harder as the blood is thicker, so would flow less easily through the blood vessels to the working muscles. And due to this, this would then decrease performance, meaning that the performer would fatigue much quicker than compared to if they were hydrated. The third waste product is heat production. As aerobic respiration is an exothermic reaction, this causes an increase in core temperature, and as this increases, the body will try to get rid of this heat or excess heat to create homeostasis once again. So they would try to thermoregulate the body, meaning that they would distribute more blood to the skin so that heat can be lost easier at the skin. This means that less blood is then traveling to the muscles, meaning that the muscles are receiving a lower volume of oxygen. And so if this isn't, so over time, this would mean that the performer would fatigue as the muscles aren't getting as much oxygen to the muscles as before, meaning that they would start to fatigue and rely anaerobically. In extreme cases of where the body can't thermoregulate to a sufficient amount, this could cause hyperthermia, otherwise known as heat exhaustion, where the performer would eventually get heat stroke or collapse if they don't stop. In the neuromuscular system, fatigue can be caused in many different ways. The first being through the axon of a nerve. For an impulse to travel down a nerve, depolarization occurs down the axon as the impulse jumps down the nodes of Ranvier, and this is caused by sodium moving into the axon and potassium moving out of the axon, causing a change in sign of positive to negative. Once this is completed, the axon needs to repolarize, meaning that the positive and the negative then need to switch back. And during this, some potassium ions are then lost. And as potassium ions are lost over time, not enough sodium and potassium ions would be present to be able to repolarize the axon. So then the next impulse and further impulses from that wouldn't be able to travel down the nerve, meaning that the muscles that need to contract won't receive that impulse to contract, meaning that the performer would fatigue and have to slow down, and in some cases eventually wouldn't be able to contract their muscles anymore and would physically have to stop. Another way in which the neuromuscular system would fatigue is at the neuromuscular junction. Acetylcholine diffuses across the synapse to receptor sites, and to transport the impulse from the nerve cell into the muscle cells. After prolonged periods of time, the ACH or the acetylcholine would decrease, and eventually, as this decreases over time, there wouldn't be enough to trigger an impulse at the muscle fiber, known as the all or none rule, as there wouldn't be enough to trigger an impulse at the muscle fiber. Eventually, none of the muscle fibers connected to that nerve will carry that impulse, meaning that none of those muscle fibers would eventually contract. Another way in which the neuromuscular system would fatigue during low intensity hydration is that also at the neuromuscular junction, after the ACH has sent its impulse to the receptor sites, the enzyme known as cholinesterase needs to break down that ACH. But after prolonged periods of time, there would be this cholinesterase won't be able to work fast enough to clear all the ACH, meaning there will be an excess amount of ACH left, or the cholinesterase would slowly deplete, meaning that there wouldn't be enough to clear the ACH from the receptor sites. And that means that a new impulse can't be sent down to the receptor sites, meaning that an impulse can't be carried on into the muscle fiber, and so the muscles can't contract due to that. Another way in which the neuromuscular system causes fatigue is through calcium ions, and this is once it's entered the muscle fiber, it reaches the sarcoplasmic reticulum and would bind and release calcium, and this calcium binds to troponin, which then releases the actin binding site for the myosin to bind to during the sliding filament theory. But over time, this the calcium stores would either deplete or wouldn't. The sarcoplasmic reticulum wouldn't release sufficient amount of calcium, and that means that the actin binding site would be covered as the troponin can't bind to that calcium, meaning it would cover the actin binding site, so the myosin wouldn't then be able to bind with the actin and cause the sliding filament theory. One last way in which hydrogen ions, which the neuromuscular system causes fatigue, is hydrogen ions, and this is the production of lactic acid causes the formation of hydrogen ions, and as this builds up, this would cause a reduction in the velocity and force of the contraction, meaning that the body physically has to reduce intensity. So as the hydrogen ions build up, this would then prevent enzymes from allowing the process to produce ATP in contractions. And this means that the body or the muscles would eventually fatigue, and as they fatigue, then the velocity and the force of that contraction would be reduced, with the fast glycolytic muscle fibers being the first muscle fiber type to stop working altogether and